The first question is cosecant minus cot theta the whole square is equal to 1 minus cos by 1 plus cos. So just take an LHS and prove the RHS. Okay. So I am taking the LHS. First step is what? You have to change every ratio in terms of sine and cos. So cosecant theta can be written as 1 by sine. Cot theta can be written as cos by sine, right? The whole square is there, so I am writing the whole square. So 1 minus cos theta by the whole denominator sine theta. Since both have denominator sine theta, I am writing whole denominator as sine theta. And send the square inside to the numerator as well as denominator. 1 minus cos theta the whole square by sine square theta. So next what can we do? Don't expand using a minus b the whole square formula. Why? No, you have to learn, like you have to first check out the proof. You have the numerator as 1 minus cos theta, right? You have the denominator as 1 plus cos theta. So in the numerator, we already have 1 minus cos theta. Only thing is the whole square is there. So always remember, when you're solving the proving problems, you need to remember the proof, like RHS. What is RHS? You need to keep the RHS in your mind and then try solving for the RHS. Okay. Don't just solve blindly, like you can just go with the a minus b the whole square like that. No, if you do, you won't get this proof. You will get some other answer. So to get this proof, I wanted the numerator as 1 minus cos. It is already there, but the whole square is there. I have to eliminate the square. That's all, right? So I am going to write sine square as 1 minus cos square theta. So it is like 1 minus cos square theta. So 1 minus cos square theta, I can also write 1 as 1 square, right? So it never changes. 1 square is also 1, right? The value never changes. So I'm writing this as a square minus b square formula so that I can expand a plus b into a minus b. So 1 plus cos theta into 1 minus cos theta. 1 minus cos will get cancelled, and in the new denominator we have 1 plus cos. So this is our RHS, 1 minus cos theta by 1 plus cos theta. We got it, right? So first step is to change in terms of sine and cos, and second step, you remember the RHS and solve accordingly. Okay, so here 1 minus cos we need, so I am going to change the denominator sine square as 1 minus cos square and writing it in the form of a square minus b square, expanding through a plus b, a minus b, I can get cancel, get the RHS. Okay. Second question, they have given cos a by 1 plus sin a plus 1 plus sin a by cos a, which is equal to 2 secant a. Can you see the LHS is already in the form of cos and sin? So first step is done, right? So second step is to take an LCM. If you have to take LCM, you have to take LCM. So cross multiply it, take an LCM. Okay, 1 plus sin into cos a, that is your LCM. So cos square a. So if you cross multiply cos square a into plus 1 plus sin a the whole square, right? So can you see it is in the a plus b the whole square formula, right? So write the cos square as it is. A square is 1 square, b square is sin square, and 2ab is 2 into sin a. Okay, so cos square plus sin square is 1 plus 1 plus 2 sin a. Okay, so you'll be getting 2 plus 2 sin a into 1 plus sin a into cos a. Now come back to the proof. What you need to prove? 2 secant a. Okay, so I am taking 2 common out. Okay, so 2 secant a. Secant a is what? Secant is the 1 by cos, right? So we have already denominator as cos. So you need to eliminate this 1 plus sin a. So for to eliminate this 1 plus sin a, I am taking 2 common out. 1 plus sin a, 1 plus sin a will get cancelled. So 2 by cos a means you can write as 2 into 1 by cos, which is 2 secant a. Okay, so first step is done. The question is already in the cos and sin form. So take an LCM and expand it through a plus b the whole square formula and solve according to your RHS. Third question is very important. Tan theta by 1 minus cot plus cot theta by 1 minus tan theta. You're going to prove it is 1 plus secant cosecant. So first step is to change everything in terms of sine and cos. Tan theta can be written as sine by cos. Cot theta can be written as cos by sine. And here also cot is cos by sine, tan is sine by cos. So next step is to, in the denominator, take an LCM, like take cross multiply it. Sine minus cos by sine, cos minus sine by cos, right? So now just take the denominator, reciprocal it to the numerator. So denominators here, this will come to the numerator, right? Sine theta by sine minus cos. And here cos by sine you write as it is, and this you are going to reciprocal it, cos theta by cos minus sine. So now can you see, in the denominator here we have sine minus cos, but here we have cos minus sine. So if you get like this, no, just make it even, like the same sine minus cos I need it here. To get it, I am taking minus common outside here. If I take minus outside from this bracket, no, so minus this becomes sine theta minus cos theta. Like if you multiply this minus inside, the value never changes. Minus sin theta plus cos theta. The same value will come. But to make it even to this denominator, I am taking minus common outside. So once you take minus common outside, no, just write numerator sin into sin square divided by cos into sin minus cos, plus cos into cos square, sin theta into, like you have minus, no, minus sin theta into sin minus cos. So this minus will go this place, right? So now take the denominator common outside. What is the common denominator? Sin theta minus cos theta, right? So since it is a denominator, I am taking 1 divided by sin theta minus cos theta outside commonly. You are taking common out. So remaining in the first term is sin square theta by cos theta, and here we have minus, right? So write this minus here, cos square theta by sin theta. So next step is to cross multiply and take an LCM. Sin cube minus cos cube by sin theta cos theta. Okay, so this is like a cube minus b cube formula, right? You have to expand it through the formula. What is a cube minus b cube? A minus b into a square plus b square plus ab. Here a is sin, b is cos. So a minus b means sin theta minus cos theta. A square sin square plus b square is cos square plus ab is sin theta cos theta. So can you check out sin square plus cos square is 1, right? And you can cancel the sin minus cos, right? This is in multiplication. You can cancel this and this becomes 1, right? 1 plus sin theta cos theta. So you can cancel this and remaining is 1 plus sin theta cos theta by sin theta cos theta. So when you got like this, I am going to, this denominator is common to both the terms, no? In the numerator we have two terms. I am going to separate these terms with the denominator. So 1 divided by sin theta cos theta plus sin theta cos theta divided by sin theta cos theta. What is 1 by sin? Cosecant, right? 1 by cos is secant. And you cancel this plus 1. So this is your proof. 1 plus secant cosecant, which is RHS. So this is very important, but you need to understand the concept. First steps, again I'll repeat this concept. Okay, so first step is to change in terms of sin and cos and take cross multiply it and take this denominator to the numerator by reciprocaling it. After you reciprocal, you can see sin minus cos, cos minus sin. So I want the same denominator, so I am taking minus common outside. After this you'll be getting like this. So here denominator is common, so I am taking common out. So remaining terms I am writing it here, cross multiply it, you get the formula of a cube minus b cube. So you can expand it like a minus b, a square plus b square plus ab. So you just write it as it is and cross, and you can get cancelled with this. You will end up with this. So 1 by sin cos plus sin cos by sin cos. So you can get cancelled. This is secant cosecant plus 1. 1 plus secant cosecant is your RHS, right? So fourth question, 1 plus secant A by secant A. You need to prove this. Okay, take an LHS. So you are going to change in terms of cos or sine, right? So secant is the inverse of cos. So I'm writing secant as 1 by cos. Okay, so cross multiply it. Cos A plus 1 by cos A divided by 1 by cos A. Cos will get cancelled. You'll end up with 1 plus cos A. So you just conjugate multiply it by multiply and divide it by 1 minus cos A. 1 minus cos A. So if I multiply and divide it by 1 minus cos A, can you see numerator is A plus B into A minus B? So I can write it as A square minus B square. 1 square minus cos square. Okay. So I'm writing it as 1 minus cos square A by 1 minus cos A. What is 1 minus cos square? Sin square. Sin square by 1 minus cos A, which is your RHS. So first change in terms of cos and then cross multiply, take an LCM and multiply and divide it by 1 minus cos A. Fifth problem, cos minus sine plus 1, cos plus sine minus 1. This is also very important. So you have to prove cosecant plus cot. So you first step, no, for this proof, this is one or two questions of exceptional. You need to start with dividing both numerator and denominator by sine. Why I am dividing by sine? Because the proof is cosecant plus cot A. So I am changing every cos and sine in terms of cosecant and cot to get the easy method, like to solve in easy method. So divide both numerator and denominator by sine A and take and divide each term cos by sine, okay, minus sine by sine plus 1 by sine divided by cos by sine plus sine by sine minus 1 by sine. So what is cos by sine? This is cot. Sine by sine will be 1. 1 by sine is cosecant, and here cot plus 1 minus cosecant. So I am changing every cos and sine in terms of cosecant and cot A, so that I am for that I am dividing a numerator and denominator by sine. Okay, so I am just grouping cot plus cosecant minus 1 here, keeping the minus 1 here, cot plus 1 minus cosecant A in the denominator, I am keeping it as it is. So after this step, just listen carefully. So instead of this one, I am substituting the identity. We know the identity, cosecant square minus cot square is 1. So instead of the 1 value, I am substituting the identity. Cosecant square A minus cot square A. Since this is also 1, right? So I am substituting in the place of 1, I am writing the identity. Cosecant square A minus cot square A. Can you see it is A square minus B square formula? So I am expanding A minus B, A plus B. So this is one term, this whole is one term, right? So in the two terms, what is common? Cot plus cosecant is common, right? Cosecant plus cot A, cosecant plus cot A. So take the common out in the numerator. Cot plus cosecant, I am taking common, okay? So remaining is in the first term, we have taken cot plus cosecant out, so you will end up with 1. And in the second term, we have taken this common, so minus cosecant, you multiply the minus inside, minus cosecant plus cot A, okay? So 1 minus cosecant plus cot A. So you have taken cot plus cosecant A common out. So in the first term, you will end up with 1 minus cosecant plus cot A. You multiply this minus inside, okay? So after this, can you check, like it looks like the denominator, no? Denominator is cot plus 1 minus cosecant A. Here also cot plus 1 minus cosecant A. I am rewriting as it is and cancelling this denominator with the numerator. So remaining is cot plus cosecant A.